Assalamu alaikum students. I'm here with another question, and as I told in the first video that I'm doing mechanics, kinematics. This is question number 3 from May June 2017, and question paper is 43. Okay, I'm doing exam questions for making you ready for this question, like the question which is coming from this topic. So I'm doing some question from exam paper. I will be doing maybe 10 to 12, 13 questions. I'll be doing the same topic from different exam papers, so that you are ready for your exam. If you are giving your exam or your test, inshallah this will help you in that. Okay, this question is: a train travels between two stations A and B. The train starts from rest at A and accelerates at a constant speed, a constant rate. I have told you, here we are doing questions where the body or the object or someone, the car, the vehicle, that's moving with constant acceleration. Okay, so it's moving with constant acceleration, constant rate, and for t seconds until it reaches a speed of 25 meters per second. The first thing is the train starts from rest. Rest is always like the initial starting point, it's 0 here. So rest starting from here, it's 0, and this point is point A. Now, and accelerates at a constant speed. Now see, constant speed, this is constant speed. You see, this is constant speed. Constant acceleration. Acceleration at this point, at this point, at this point, at this point, at this point is same. So this is basically the example for the constant acceleration, either if this way or that way. This is acceleration and this is d. If the body is moving this way, then it's deceleration. Okay, now then they say it then travels at this constant speed before decelerating at a constant rate. Okay, then they say it's moving then with constant speed, and we know that if the object is moving with constant speed, the graph will be this way. The constant speed is showing a straight line parallel to the x-axis. This is basically parallel to x. Sorry, let me okay, parallel to x axis. So here this is called constant speed. Now we have done these things in IGCSE mathematics. These are basically things which are done to you in IGCSE math. Okay, now then it decelerates at a constant rate, coming to rest at point B. Let's say point B is somewhere here. Okay, let's say point B is here. The magnitude of the train's deceleration is twice the magnitude of its acceleration. Okay, here is one thing given to you. They say magnitude of deceleration is two times the magnitude of the acceleration. So this is a very important statement given to us here. Now I want to make it clear to you that what happens if the magnitude of the acceleration is twice of the other one, or what happens if the magnitude of the deceleration is twice of the acceleration given at any other point. I am giving a small example here. I want to show basically what happens with the diagram. See, 1 2 3 4, 1 2 3, 4. Look here, if I say starting from here and ending here, so what is the acceleration here? It's, of course, you will say, sir, it's 4 by 4, so it's 1. Okay, now if I say, I'm changing the color for your understanding, if I say I'm coming here, what is then the acceleration? So you will say to me, sir, it's rise. In the red case, rise is 4. What's the run? 2. So 2 is, look at the steepness, there is change in the steepness. Okay, so when the acceleration is double, then the steepness will be different than the acceleration single, it's more steeper. Okay, now see here, so from in the first case, the train starts from rest at A and accelerates at a constant rate for t seconds. I'm writing t here. Accelerates yes, I'm reaching here. Now, okay, they say accelerates at a constant rate for t seconds until it reaches a speed of 25. So this it reaches here, this is 25 meter per second. Now then they say it then travels at this constant speed before decelerating. So it's from here, it's moving the same constant speed before it decelerates. Now what will happen? Okay, one more thing here, look at here, these are 4 seconds, let's say. How many seconds are here? These are 2 seconds. So if this is t seconds, that is, see, 4 seconds and 2 seconds. So this will be from here till here, I say this is B. So from here I'm drawing a line here. Now steeper line, and according to the rule, this time will be t over 2, because more steeper and acceleration double up that, so time will be half. Okay, that's important thing. If acceleration magnitude is double of the previous one, then time will be half of that time. So this was t, that is t over 2 from here. This point is B. Okay, now that's a diagram. I got a diagram, and that's the question, the first part, and giving you 1 mark. Now find an expression in terms of t for the length of time for which the train is traveling with constant speed. Okay, here's one thing given to us. They say the total time taken for the journey is 180 seconds. Now this from 0 to this point, from 0 second to this point, t seconds are there. From this to this place, see, from this to this, from here to this place, from here I'm doing with a different color. Look at this time. This time is t over 2. The total time is what? Total time is 180 seconds. Okay, so they say find an expression for find an expression in terms of t for the length of time for which the train is traveling with constant speed. They want the time from here to here. So this time is required. Let's say this time is from here to here. This time is x. Now look at this thing. Total time is 180 seconds. Okay, and this is basically t plus x plus t over 2. Is it correct? Yes, of course it's correct. This is t seconds, these are x seconds, and this time is t plus 2 t over 2. Now what is the time taken from this point till this point? So it's 180 minus t over 2, which is the time taken for this much traveling, where the speed is constant. So it's 180 minus 2t plus t over 2, which is x. So it means x is 180 minus 3t over 2. That's the result for part 2. The distance from A to B is 3,300 meter. Find how far the train travels while it's decelerating. Okay, when it's decelerating, how far a train is traveling? Deceleration is in this green area. Okay, now look here. See what we are doing here. Basically, this distance traveled from A to B is this. Find how far a train travels while it's decelerating. So basically we are finding the time, how far the train travels while it is decelerating. This time is required. See, this is required, this time is required. Here is the deceleration occurring. Okay, so this time is the time where the deceleration occurs. So they are basically, look at this sentence, how far the train travels while it is decelerating. How far a train travels, for how many seconds it's traveling when the train is basically decelerating. Okay, now how to do it? Look at this thing. First we will find a time, then it's easy for us to get the distance. See, this is the green area, that's distance which is taken which is like the travel distance during the deceleration. Now look at the total distance, it's how much? 3,300 meter. Yeah, 3,000. Yes. Okay, total distance traveled is 3,300, which is equal to 1 over 2. Now this length is this time is how much? What is that time we got? That is basically this time, 180 minus 3t over 2 plus this time is how much? This total time, this is 180 into what's the velocity? 25. Okay, come on, get the, this is 6600, which is equal to 180 plus 180 minus 3t over 2 into 25. What I will do here with my calculator, 6600 divided by 25, I got here 264. Now this is 360 minus 3t over 2. Now okay, yeah, so this is 264 is equal to 0, 2 6 are 12, 2 3 are 7, 2 3 are 6, 7, 720 minus 3t over 2. So 2 4s are 8, 2 6s are 12, 2 2s are 4, 5 is equal to 720 minus 3t. So 3t is equal to 720 minus 528. 720 minus 528 is equal, divided by 3, 64. So time is we're getting time here 64. Now for how long, for how much time it's traveling, it's doing this traveling with deceleration. Like this deceleration is taking how much time. So deceleration, I'm changing the color, deceleration is 1 over 2 into t. Now it's 32 seconds. Now they say how far, find how far the train travels while it is decelerating. How far means how much distance it covered. So distance is 1 over 2, 32 into 25, 16, 25 into 16, I think it's so calculator, 25 into 16, yeah, it's 400 meters. That is the question and that's the solution for it. Inshallah, I will be coming with another question after some time. This is the question number 2. So okay, Wa Hafiz.